Hi, today we're looking at Functional Skills Maths Level 2. This is the AQA exam board. It's the November 2022 paper, and we're going to start with the non-calculator section. Question 1. Circle the calculation that increases 80 by 47%. Okay, well, if it's increasing by 47%, well, we're going to have the original 100% of what we're starting with, and we're going to add on 47%, so we're going to end up with 147%. Okay, now all of these, we're working with decimals instead of percentages. So if we want to turn a percentage into a decimal, we need to divide it by 100. So if we're dividing by 100, we're going to move our decimal point once, twice. So we're going to end up with 1.47. We're making it bigger because we're increasing it, so we need to be multiplying by 1.47. So the 1 means we're going to keep the 80, and the 0.47, we're increasing it, or we're adding on an extra 47%. Question 2. Write 5 divided by 8 or 5 over 8 as a decimal. So say 5 over 8 is the same as 5 divided by 8. So if we were doing this a normal division, well, we would do the bus stop method. We'd put the top number, the numerator, inside the bus stop and the denominator on the outside. Now I agree it looks a little bit odd at the moment. So what we can do is, instead of just having it as 5, we can think of it as 5.0. Okay, we're not changing the number, we've just given us a 0. So now we can say, well, how many times does 8 go into 5? Well, 8 doesn't go into 5. So we can put a 0. But we can carry the 5 across. So now we say, how many times does 8 go into 50? Well, if you think of the 8 times table, we've got 8, 16, 24, 32, 40, 48. So that's 6 times. And 49, 50, so 2 left over. So we'll put another 0 here. Put the 2 in front of the 0. So now we can say, how many times does 8 go into 20? Well, 8, 16, 24 would be too many, so it's just going to be twice. Let's get the 16. And then 17, 18, 19, 20, so that's remainder 4. So we can have another 0 and carry the 4 across. How many times does 8 go into 40? 8, 16, 24, 32, 40, 5 times. So we get an answer of 0.625. Question 3. Circle the largest number. Well, these numbers are all negative. Okay, so think of them as temperatures. If we want the largest number, but they're all negative, it would be, what's the warmest temperature? So the least negative. Well, -2 is the smallest number bit. So this is going to be warmer than -5 and -8 and -15. So the largest, when they're all negative, it means the least negative. So it's the smallest number bit. Okay. It would be different if we had some negative and some positive. Then obviously all the positive numbers would be bigger than all of the negative numbers. Okay. Question 4. An event has 4 possible independent outcomes: A, B, C, or D. The table shows the probabilities of 3 of the outcomes. So we've got the probability of A happening is 0.23. Probability of B is 0.071. We don't know the probability of C. And the probability of D is 0.538. Work out the probability of outcome C. Well, if there's only 4 possible outcomes, the total of all of those outcomes has to add up to 1, because that would be like 100%. So if we want to know what C is, well, we can add up the others, take them away from 1, and that will be our answer. So we want 0.23, 0.071, and 0.538, and add them all together. Now, this number's only got 2 decimal places, so we're going to put a 0 there just so we've got a placeholder. So 0 plus 1 plus 8 is 9. 3 plus 7 is 10, plus another 3 is 13. 2 plus 0 plus 5 is 7, plus 1 is 8. And 0 plus 0 plus 0 is 0. So these three probabilities added together give us 0.839. So now I said we need to take that away from 1. And a bit like we did before, we're going to put some zeros in here so we've got something to take them away from. Well, we can't take 9 away from 0. So what we're going to have to do, we can't take anything from this 0 or this 0. So we're going to reduce the 1 to a 0 and pass the 1 across. Now we're going to have to keep passing this 1. 1 less than 9 is a 1 less than 10 is a 9, and pass the 1 over. Need to do the same again, reduce it to a 9. So now we've got our 10 here. So we can say 10 minus 9 is 1. 9 minus 3 is 6. 9 minus 8 is 1. 0 minus 0 is 0. So you get 0.161. If you find this bit complicated way of doing it, what you can do is you can start with the 0.839 and think, what do I need to add to it to get up to 0? Well, to get from 9 to 0, we need an extra 1, but then we carry 1 over. So 3 plus 1 is 4. To get up to 0 or 10, we need to add an extra 6. But because it's 10, we carry the 1 over. 1 plus 8 is 9. To get up to 10, we need 1 more. So we can get the 0.161 that way as well. So adding on instead of taking away. Question 5. Work out 2, and then we've got bracket, 9 squared minus 31, close bracket, all over 5. Okay, so we're going to use our order of operations here. Now, because all of this is on the top of the fraction, all of this is going to be done before we do the 5. And if you remember BIDMAS rules, what's in the brackets needs to be done first. So in fact, I'm just going to write what's in the bracket over here. 9 squared minus 31. Okay. Well, we've got a power here, or indices, so we need to do this bit before we can do the subtraction. So the 9 squared means 9 times by itself. So 9, 18, 27, 36, 45, 54, 63, 72, 81. So we've got 81. So 9 squared minus 31 is 81 minus 31. And if you want to write it as a column, you'll see the 1 minus 1 is 0, and 8 minus 3 is 5. So we get 50. So all of this in the brackets up here is equal to 50. Now when you've got a number next to brackets, it's a bit like algebra this, if we haven't got a symbol in there, there's an invisible multiply sign. So this actually means 2 times 50, then divided by 5. Now this is still all on the top of the fraction, so we've still got to do this bit before we can do the division. So 2 times 50, well, you might be able to do that one in your head. If not, we can do 2 times 0, 0, 2 times 5 is 10. So we've got 2 times 50 is 100, and that is over 5, which is the same as 100 divided by 5. Or if we want to do bus stop method, we can say 5 into 1 doesn't go. 5 into 10, you've got 5, 10, so that's twice. 5 into 0 goes 0 times. So we end up with an answer of 20. Okay. Question 6. Fruit and vegetables. Alana grows fruit and vegetables in her garden. 6a. Alana wants to change the layout of her garden. Alana wants to have a rectangular vegetable patch, 3 metres by 15 metres. So let's do a quick sketch of that. So 3 metres by 15 metres. A rectangular greenhouse, 4.5 metres by 6 metres. So this would be something like, more like that. And this is just a sketch so we can kind of visualise it. A circular fruit patch with a radius of 3 metres. Well, what I'm going to do is I'm going to draw a sketch of this one over here. So circular, there's my circle, and a radius, well, that's the distance from the centre to the edge. That's 3 metres. Okay. And we're told the centimetre grid represents a scale drawing of the garden. Draw and label a possible plan for the garden on the grid. Use the scale 2 centimetre represents 3 metres. Okay, well, if these are centimetres, so what we're saying, 2 centimetres, so that is equal to 3 metres. Okay. So, what we can do is we're going to work out how many squares on this grid we're going to need for each of our pictures, and then we can try to put them on. So, if we know that 2 centimetres represents 3 metres, well, with our rectangular vegetable patch up here, well, this length is 3 metres. So this is going to be 2 centimetres on the diagram, okay? Because 3 metres represents 2 centimetres, or the other way around. If we want to work out how many centimetres is going to be across, well, 15 metres, if you think, how many times does 3 go into 15? Well, 15, what should we do? Let's do it down here. 15 divided by 3, we've got 3, 6, 9, 12, 15. So 3 goes in 5 times. So we're going to have 5 lots of 2 centimetres across here. Well, 5 times 2 gives us 10. So this is going to be 10 centimetres on our diagram. Okay. In fact, I'm going to draw that one on first so we can work with that. So we need it to be 10 squares or 10 centimetres. 1, 2, 3, 4, 5, 6, 7, 8. Well, it's not going to go that way. It's going to have to go lengthwise down our diagram. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to go down to here. And remember, we wanted 3 metres, so it's going to go out to here as well. So if I get my ruler, we'll draw this on. And I'm drawing it right over by the side, just to keep it out of the way, so we've got more space for everything else. And this is going to be our veg patch. Okay. Now we've got our rectangular greenhouse, and this is 4.5 metres by 6 metres. So, well, let's go with the 6 metres first of all, because I can see that 6 metres is 2 lots of 3 metres. And so 2 lots of 2 centimetres means that's going to be 4 centimetres. Okay. Now we need to get this measurement. We want 4.5 metres. Well, that one's a bit trickier to get. So what we can do is maybe think, well, if 2 centimetres is 3 metres, what's 1 centimetre going to represent? Well, 1 is half of 2. So we want half of 3. And half of 3 is 1.5 metres. But this looks quite good now, because I'm trying to get 4.5 metres, and I can see, well, if I add these two together, 3 plus 1.5, that's going to give me 4.5 metres. So if I add 2 and 1 centimetres, I'm getting 3 centimetres. So 4.5 metres in real life is going to be 3 centimetres on the diagram. So I need to draw a rectangle that is 4 centimetres by 3 centimetres. Well, let's do it up in this corner. So if we start here, we'll go 1, 2, 3, 4 across, and 1, 2, 3 down. And making sure I use my ruler, nice straight lines. And this is our greenhouse. Now, finally, we've got a circular fruit patch with a radius of 3 metres. So this is our circle. So 3 metres. Well, we know from the scale that 3 metres is 2 centimetres. So we want a circle with a radius of 2 centimetres. Well, let's just pick somewhere and see if it's going to fit. So if that's my circle, if that's the centre, 2 centimetres, 1, 2 would be there. That's the side. 1, 2 at the top would be there. 1, 2 there, and 1, 2 down here. So you can use your compass, if you've got a compass, and use that to do a perfect circle, or you can try and sketch it. Now, I would recommend you use a compass in the exam, but not everyone has one, or not everyone is comfortable using it. So, just to show you can sort of do a freehand one here. So it will look prettier if you use a compass, but you can do it without. And you would still get the marks if you do something that looks approximately like that. And we're going to label this fruit patch. So if you've got a compass, you're happy using it, use it. If you aren't comfortable using it, well, now you've got time to practice, so give it a go. If you can't get comfortable, then, as I say, you can try and sketch it. But it is nicer if you can do it using the instruments. (6b). Last year, Alana grew raspberries inside in her greenhouse and outside on her fruit patch. Here is the data for the 10 raspberry plants grown inside. So these are the number of raspberries per plant. Gosh, did quite well. We've got 324 on this plant, 297 on this one, and so on. Here is some information about the raspberry plants grown outside. Now we've got the number of raspberries per plant. They don't tell us how many plants, but we're told the median is 298 and the range is 78. This year, Alana wants to grow all the raspberries in the place where the number of raspberries per plant has the higher average and is more consistent. Should she grow the raspberries inside or outside? Show working to support your answer. Okay, and we've got 5 marks for this question. Now, the higher average, should be comfortable with knowing what this means. The averages, it could be the mode, it could be the median, it could be the mean. They've given us the median for the outside ones, so I think it'd be good to be consistent with that and work out the median of these for inside. Now, what they mean by is more consistent, this is saying that the number of raspberries on a plant doesn't change so much. So the consistency can be worked out by using the range. Okay, so whichever's got the smaller range is going to be more consistent because there's less change or less variation. Right, so we need to work out the range, we need to work out the median. Let's start off, let's do the median first of all. So to do the median, we want to find the middle number. Okay, and to do that, we need to rank these in order from smallest to largest. So what's the smallest one? 297, anything smaller? Or 293? Yeah, so this is the smallest, so I'll label that 1. Then 295. Then 297. Then I think all the others are in the 300s. 304, anything smaller? 301, so that's next. And 304. 20, then 310. Then we've got 320. 321. 324. And the biggest one, 333. Okay, so I've numbered them there first of all. And now I'm going to write them out from smallest to largest. So the smallest was 293. Then we had 295. Then 297. 301. 304. 310. 320. 321, 324 and 333. So we want the middle number, so we're going to start by crossing off the smallest and the largest. And we're going to keep doing that in pairs until we get to one number in the middle, or because we've got an even number of values here, we're going to end up with 2 in the middle. Now when you've got 2 in the middle, we need to add them together. And then divide it by 2. Well, let's add these 2 together first. 4 plus 0 is 4. 0 plus 1 is 1. 3 plus 3 is 6. Okay, now we need to divide that by 2. So 614 divided by 2. 2 goes into 6. 2, 4, 6, that's 3 times. 2 can't go into 1 because it's smaller, so we carry the 1 over. 2 goes into 14. 2, 4, 6, 8, 10, 12, 14. That's 7 times. So we've got a median. So this is for outside. And inside our median is 307. So we want to work out the range now. Remember the range is equal to the biggest minus the smallest. So what's the biggest value? Well, it's going to be the number 10. So it's going to be this 333. And the smallest was 293. So 333 minus 293. 3 minus 3 is 0. 3 minus 9 you can't do. So take 1 from the 3, reduce that to a 2. Now we've got 13 minus 9, which is 4. 2 minus 2, which is 0. So we've got a range of 40. Now she wants to grow the raspberries where it's got the highest average. Well, the highest average is this one. And is more consistent. And we said that means the smallest range, which is that one. So both of them are suggesting inside. Okay. So if we wanted to be complete, we could say she should grow the raspberries inside because they have a higher average, and we can put median equals 307 versus 298. You can write sort of shorthand. And they are more consistent because the range of raspberries per plant is only 40 compared with 78. Now you wouldn't need to write all of this, but I'm doing this so that you can kind of get a feel for what this actually means rather than just saying this one, that one. Yeah, I'm kind of spelling it out. Say, if you just give your figures, that would be enough. But if you want to put a sentence, try to explain what's going on. That might help your understanding as well, and that would be really good. C. Alana wants to make raspberry jam. She uses this recipe. Raspberry jam, mix 2 kilograms of raspberries with 2.4 kilograms of sugar. Alana has 3.5 kilograms of raspberries and 4 kilograms of sugar. Alana wants to use all the raspberries. How much more sugar does she need? Give your answer in grams. Right, so I'm going to treat this like a ratio question. So I'm going to say, well, so we've got our raspberries, or I'll call them rasp for short. We've got sugar. Let's see if that's going to be enough for now. So we know that if we've got 2 kilograms of raspberries, we've got 2.4 kilograms of sugar. We want to know how much sugar we need for 3.5 kilograms of raspberries. So the first thing I'm going to do is say, well, how much do we need for 1 raspberry? Well, 1 is half of 2. So if we do 2.4 divided by 2, do by stop method, 2 goes into 2 once, 2 goes into 4 twice. So 1 kilo of raspberries is 1.2 kilos of sugar. We're still not quite up to 3.5 kilos of raspberries yet. But what we can do is think, well, if we want to get 3.5, we can go from 1 straight up to 3.5 by multiplying by 3.5. That means we need to do the same to the amount of sugar. Okay. Now you could do 1.2 times 3.5, or you can think, well, I've got 1.2 and another 1.2 and another 1.2, which is my 3 lots of them. Then I want half of 1.2. Okay, so 1.2 divided by 2. Well, ignore the decimal point to start. If I had 12 divided by 2, it would be 6. But we've got 1 decimal place, so we're just going to put the decimal point in there, and we're going to have 0.6. So this is 3.5 lots of 1.2. So 2 plus 2 is 4, plus 2 is 6, plus 6 is 12. 1 plus 1 plus 1 plus 1 is 4. So for 3.5 kilos of raspberries, we need 4.2 kilos of sugar. Okay. We've already got 4 kilos of sugar. So to find out how much more we need, we take the total amount we need, subtract the amount we've got. So we've got something to take away from it. We can put a 0.0. So 2 minus 0 is 2. 4 minus 4 is 0. So she needs 0.2 kilograms. Now, don't stop there, because they've said give your answer in grams. Okay. You could have converted to grams at the start of the question. I think it's maybe easy to keep them in kilograms up until now. But what we need to know is that we've got 1,000 grams in 1 kilogram. So if we want to turn 0.2 kilograms into grams, we want 0.2 times 1,000. So we take our 0.2, multiply by 1,000 is going to make it bigger. Got 3 zeros, so we're going to move that decimal point 1, 2, 3 times. Fill that in with zeros, and we get 200 grams. And that's the end of the non-calculator paper. Okay, so now we're on to the calculator section. Question 1. Circle the integer. This one you just need to know what integer means. And if you don't, you're going to find out, because integer just means a whole number. Okay. So it can't be a fraction, can't be decimal, must be the 7. Question 2. Right, and I'm going to put my commas in. So I'll start from the end and go 1, 2, 3, comma, 1, 2, 3, comma. So now it's easier for me to see. I know this first one gives me my thousands, the next one gives me my millions, so I must have 9 million. And it says in words, so all need to be words, 9 million. Then we've got 507. So 500 and 7. And 507 what? Well, it's 1,000. And comma. And what's left? 211. Very good. Question 3. Work out 3 years to 9 months as a ratio. Give your answer in its simplest form. Right, well, instead of writing 3 to 9, we've got different units. We've got years, we've got months. So let's turn the years into months. Well, we've got 12 months in a year. So 3 times 12, 3 2s are 6. 1 3 is 3. So we've got 36 months in 3 years. So 3 years to 9 months is going to be the same as 36 to 9. Now, if we want to write it in its simplest form, we want to look at numbers that go into both 36 and 9. You could do 3, which would be fine. Or you might say actually 9 goes into both of these, because 36 is in the 9 times table. So 9 goes into 36, 9, 18, 27, 36. 4 times, and 9 goes into 9 once. So you could divide them both by 3, but if you did that, you'd end up with 3 goes into 36, 12 times, and goes into 9, 3 times. So you could then simplify this again. You'd then divide both by 3, which still gets 4 to 1. Okay, so if you can see it, you divide by 9, you do it in one step. But if not, and you divide by 3, and divide by 3 again, that's okay. Might take a little bit longer, but you still get the right answer. Question 4. On the grid, plot and label the points X, Y, and Z. Yeah, right, so you've got to remember that the first number we get is the X coordinate. So I'll move this up so we can see our values here. So we start with 3, so this is our X, so we go across to the number 3, and our Y value is 5, so we go up to 1, 2, 3, 4, 5. So this is X. Now for Y, it's 5, so we're going to start here, but our Y value is minus 3. So stay at 5, but we go down to minus 3. So I'll put a cross there, but then I'm labelling it with a Y. And Z is at minus 3, minus 5. So minus 3 on the X axis is here, minus 5 on the Y is down here. So that's my Z. And that's it. Okay, write the mathematical name of this solid shape. These are ones you either know them or you don't. If you don't know them, then have a look, do a Google, find out your 3D shapes that you need to know. This is called a triangular prism. Okay. Or you might think of it as a tent. Okay. Now, the main 3D shapes you want to know are a sphere, a cuboid, triangular prism, a cone, a square-based pyramid, a triangular-based pyramid, and a cylinder. That's probably all you'd need to know for your 3D shapes. Question 6. Calculate 2 1/5 plus 1 3/4. Right. What can we do with this? Well, we can think of this as 2 1/5. So think of it as like 2 plus 1/5 plus 1 3/4. Okay. Or 2 plus, well, what's 1/5? Remember, we've got our calculator here. So we can say 1 divided by 5 is 0.2. Then we add on a 1, and then we want 3/4, which is 3 divided by 4, which is 0.75. Yeah, so we're using our calculator to help us on this one. So we can do 2 plus 0.2 plus 1 plus 0.75, and we get 3.95. Question 7. A triangle has an area of 20 centimetres squared. The base of the triangle is 8 centimetres. Work out the perpendicular height. So the perpendicular height means in a straight line. So not this sloping height, but straight up here. Work out the perpendicular height h of the triangle. Well, you need to remember your formula for the area of a triangle. And the formula for the area of a triangle is half times the base times the height, which in this case is going to be a half times 8 times h. Right, well, we don't know what h is yet, but we can do a half of 8. We can use our calculator, or hopefully you know half of 8 is 4. So 4 times h, or 4h. We do know that the area is 20 centimetres. So what we can say is actually 20 is equal to 4h. So 4 times something gives us 20. Rearranging is the same as saying, well, what do I need to multiply 4 by to get 20? Is the same as, well, what's 20 divided by 4? And let's see, you can go to your calculator. H is 5 centimetres. And we can write that one in here. Okay. Question 8. Calculate 2 7 plus 3k when k equals minus 1.8. Remember, when we got a number next to a bracket or next to a letter, it means multiply. So let's write this out a bit clearer. So it's going to be 2 times, I've still got my bracket, 7 plus 3k. So that means 3 times minus 1.8. I'm going to put the brackets around the minus 1.8 to show that that minus, it's not an operation, it's a negative sign. Okay. Right, so what order do we need to do this? Well, we've got to do our brackets first. So inside the brackets, so ignore this. But inside the brackets, I've got a plus and I've got a multiply. Well, the multiply needs to be done first. So we want the 3 times minus 1.8. So we'll do 3 times 1.8 minus, gives us minus 5.4. We've still got the 2 times. We've still got the 7 because we haven't done anything with that yet. But instead of 3 times minus 1.8, we know that this is now, well, it's minus 5.4. Now, if you've got a plus and a minus together, the minus wins. So we've got 2 times 7 minus 5.4. So the 2 still hasn't been used, so it stays in exactly the same place, the 2 times. But 7 now minus 5.4. So 7 minus 5.4 gives us 1.6. Multiply that by 2, and we get 3.2. Question 9. Lorry driving. Asher is a lorry driver. Asher drives from Southampton to Leeds. The journey is 380 kilometres. It takes 5 hours and 30 minutes. The graph can be used to convert between miles and kilometres. Okay, so the way you can do that, if we pick a point, try and pick a point, somewhere like this is really handy because it's going right through the line. So we can say, well, 25 miles is the same as 40 kilometres. Okay, that's a nice easy one. And Asher works out his average speed is over 40 miles per hour. Is he correct? You must show you're working. Right, so how do we want to do this? Well, let's say that this gives us a guide here with the 40. But what I'm going to do is, we want to convert from 380 kilometres, we want to turn that into miles, but we haven't got 380 kilometres on the chart here, it only goes up to 50. But maybe if we think, well, what about if we just take the 0 off the end? Divide by 10. So what would 38 kilometres be? So if I draw a line up here from 38, that's going to hit about there. And if I then read across, it's about, very approximately, it's here. So it's 1 down, so it's 24 miles. So we can say 38 kilometres, well, 38 kilometres is 24 miles. So 380 kilometres, we put the 0 on, is going to be 240 miles. Now, he's trying to work out his average speed. He says it's over 40 miles per hour. Well, he is doing 240 miles in 5.5 hours. So if we divide 240 by 5.5, we're going to find out his speed. Which gives us 43. I'll round it to 1 decimal place, so that's less than 5, so just 43.6 miles per hour. So miles per hour, so the miles divided by the hours. Well, that is more than 40 miles per hour. Is he correct? Yes, he is. (9b). The amount Asher is paid each week is calculated using the formula P equals 0.73 and then brackets, so times 0.14d plus 65n. Remember, a number next to a letter or next to brackets, we've got a multiply sign in there. So if we want to write this out, we've got 0.73 times, have our brackets, and it's 0.14 times d. D is the distance driven in kilometres that week. Well, last week Asher worked for 5 days. His pay for last week's work was £605.17. how many kilometres did Asher drive last week? Right, so we haven't got the D. We don't know how far, so we're just going to keep that as a D. But we've got to 65, and the N is the number of days worked, which we're told is 5. So we can put the 5 in there. Now, the pay in pounds, we're actually told the pay in pounds, so all of this is 605.17. So they're getting you to do a little bit of algebra with this one. So we've got everything we need, but we've just got to rearrange it. Well, what we can do, we can start to do bits of the calculation that will work for us. So we've got 65 times 5. So we can do that with the calculator. That's 325. Okay, so if I say that this is 0.73 times, well, I'm going to write this back as 0.14D just because it's tidier. But it's now 325, still in brackets. That's equal to £605.17. We've got to somehow get down to this D, but it's really difficult because we're going to multiply it by something, then add something on, then multiply with that by 0.73. So what we need to do is we need to pick this apart. We want to get rid of the 0.73. And the way we can do that is by doing the opposite operation. So this bit in brackets, we're multiplying by 0.73. So if we divide it by 0.73, well, they're going to cancel with each other. But if we do that, we need to divide by 0.73 on the other side. So that means here we'd be left with 0.14D plus 325. But this side is now going to be 605.17 divided by 0.73. Oh, sorry, I think I pressed the wrong button. 605.17 divided by 0.73, which is 829. Okay, that's helped a bit, but still we've got 0.14D, adding 325 to it gives us 829. We want to get just the D bit. So again, we want to get rid of this thing because this isn't helping us. And we can get rid of the plus 325 by taking off 325. But if we do it over here, we've got to take off 325 over here as well. So that means we end up with 0.14D. These cancel each other out. And over here, we've got 829 minus 325. So 504. So that's for 0.14D. We want just D on its own. So again, we do the opposite. If this is multiplying together, we want to divide by 0.14, which means that they would cancel. But we need to divide by 0.14 over here. So we end up with D equal to 504 divided by 0.14 gives us 3,600. And that's the number of kilometres that she drove that week. Okay. If you're not very comfortable with the algebra, it's worth practicing because, well, we've seen it's actually come up a couple of times in this paper. It can be a bit fiddly, but remember you've got 4 marks, so even if you can't do all of it, you should definitely be able to do the substitution bit. So all you need to do there is where you've got a letter and you know what that letter represents. So, okay, the D didn't help us, but the N, we knew that was the number of days. We're told the number of days is 5. So just by putting the 5 in for the N, that's going to get you a mark. All of this is going to help. Okay. Question 10. Fundraising. Carol is fundraising for a sports club. Carol designs a game. The game uses a bag containing a red ball, a blue ball, and a yellow ball, and a fair 5-sided spinner. So this is the bag with the balls, and this is our spinner over here. The player picks a ball at random from the bag, okay, one of those, and spins a spinner. The player wins if they pick the red ball and the spinner lands on an even number. Right here. Carol says the chance of winning is more than 10%. Is she correct? You must show you're working. Right, so we've got to pick a ball at random from the bag. Want it to be red. Well, the red ball, picking it from random, is 1 red out of 3 balls. So that's our probability. And with the spinner, we want an even number. Well, that's either 2 or 4. So that probability is we've got 2 numbers out of a total of 5. So those are the individual probabilities. If we want the probability of both of them happening, we need to multiply them together. If you're tempted to add them together, well, you can use logic to think, well, if the chances of getting just the ball right is 1/3, well, the chance of getting that right and something else right can't be more than that. If you are adding them together, your probability is increasing, and that can't be right. So we need to multiply them together. So we want 1/3 times 2/5. You can use your calculator, or 1 times 2 is 2. 3 times 5 is 15. Now, they were saying the chance of winning is more than 10%. Well, let's see. 2 divided by 15. Let's turn it into a percentage. Times it by 100. So that's 13.3, keep going, percent. Well, 13.3% is more than 10%. So is she correct? Yes, she is. Okay, I can't fit the whole question on, so we'll just have to move it down a bit when we get there. 10b, the club wants to use some of the money to paint the lines on a mini football pitch. The lines to be painted are the 4 sides of a rectangle measuring 27.5 metres by 36.5 metres. So 1, 2, 3, 4. A halfway line measuring 27.5 metres. So right down the middle. A centre circle with a radius of 1.5 metres. That's this here. And 2 semicircles, each with a radius of 8 metres. So here and here. So in fact, I'm going to draw on. That's 8 metres. That's 8 metres, and the radius of that is 1.5 metres. Right. It costs £3.25p per metre to paint the lines. In total, how much will it cost to paint all the lines? That's that little bit here. So we've got to work out the distance of everything that's drawn on here, all of these shapes. Okay, so what should we start off with? Probably the rectangle. That's the easiest. So for the rectangle, we want 36.5. Then we've got another 36.5 at the bottom. You could do times 2, but I'm going to write them all out. So 36.5 there, 36.5 there, 27.5 down on the right, and 27.5 on the left. And if we add those all together, and if you want to add them up any way at all, it doesn't matter, so long as you do it correctly. We get 128 metres is for that rectangle. Okay. Now we want a halfway line measuring 27.5 metres. Well, that's just 27.5 metres. So actually I'm just going to circle these so we can see these are the ones we're going to want to add up at the end. A centre circle with a radius of 1.5 metres. Well, we want the circumference. And the circumference is equal to 2 pi r. So 2 times pi times the radius. For pi, we can use 3.14. The radius we're told is 1.5. So we end up with 9.42 metres. So we can Circle that one. We're going to need to add that one on. And finally, we want 2 semicircles, each with a radius of 8 meters. So you can work out a semicircle and work out another semicircle, or you can be a bit clever here and think a semicircle and a semicircle, that's just a circle. Yeah? So it's like we've got the other half of this semicircle over here. And we don't need that one. Okay, so it's going to be the same sort of thing that we had over here. It's going to be 2 times pi times r. So 2 times 3.14. But now r is 8. And we get 50.24 meters. So those are the 4 things that they've given us. We need to add those all together. So 50.24 plus 9.42 plus 27.5 plus 128, we get a total distance of 215.16 metres. Right. It costs £3.25p per metre to paint the lines. So we want £3.25 times the total distance, which is 215.16 metres. So we've still got that in the calculator. Multiply it by £3.25. We get a total of £699.27. C. After painting the lines, the club has and I'm going to put my comma in here, £8,225. They invest 2/7 of this money in a bank account for 4 years. The account pays compound interest at 3% per year. Is the investment worth more than £2,700 at the end of the 4 years? You must show you're working. So first thing we want to do is work out what 2/7 of this amount is. So we want 2 divided by 7 times 8,225. Now, because I'm using a simple calculator, I'm going to type the number in first and then multiply it by the fraction. This will just save me having to do some rounding. Okay, look, I will show you. This gives me £2,350. If I did the fraction first, 2 divided by 7 times 8,225, I just get something that I have to round. It's doable, 2349 and then 0.99, so I'd round that up. But if you want to avoid having the decimals, you put the whole number in first and then multiply by the fraction. Right, so we've got £2,350 and it gets invested where it pays compound interest at 3% per year. So we're starting with £2,350. We're getting 3% a year, so it's increasing by 3%. So 3%, think of that as 3 divided by 100, which as a decimal is 0.03. Okay, that's 3%. Now, if it's increasing by 3%, well, we want to add on 100% to it, or a 1. So in other words, if we multiply it by 1.03, that means we're keeping the 2,350 and adding an extra 3% onto it. But we're doing it for 4 years. So this would give us the value at the end of 1 year. That would give us the value at the end of 2 years. That would give us the value at the end of 3 years. And that gives us the value at the end of 4 years. Okay, so 2,350 times 1.03. So after 1 year, it'd be worth £2,420.50. After 2 years, it's gone up to £2,493 and some pennies. After 3 years, it's up to 2,567. And after 4 years, we have got 2,644.94, but we look at the next digit, which is 5. So 5 or more, we need to round it up. So £2,644.95p. Is the investment worth more than £2,700? Well, no, that's less than 2,700. So, no. Question 11. Susie has an ice cream van. Susie buys tubs of ice cream and sells scoops of ice cream. Each scoop is in the shape of a sphere with radius 2.8 centimetres. So a sphere, think of that, it's a 3D circle. So can I kind of show a sphere with the shading there? I'm not sure if that's really helped or not. But anyway, think of it like a ball. Okay. Each scoop's in the shape of a sphere with radius 2.8 centimetres. That's the radius. And the volume of a sphere is equal to 4/3 or 4/3 times pi times the radius cubed, where r equals the radius of the sphere. Susie buys 5 litre tubs, and 1 litre equals 1,000 centimetres cubed. Susie wants to buy enough tubs to sell at least 200 scoops. Work out how many tubs Susie should buy. You must show your working. So at the moment this sounds very complicated. We've got all these formulas there, but it's got to break it down. Think, right, what do I want to know? First thing I want to know is what's the volume of the sphere? So how big is one of these scoops of ice cream? And they tell us it's 4 divided by 3 times pi, which is 3.14, times the radius, which is 2.8, cubed. So times itself, and times itself again. So the cubed means we're multiplying it by itself 3 times. So, and remember I said if you want to do the fraction last, it's not going to impact it too much. Let's do it first because it's in order. So 4 divided by 3 times 3.14 times 2.8 times 2.8 times 2.8. Okay, and we get 91 point, we'll do 2 decimal places, so 90, but 5 or more, so we round up to 91, and that's going to be centimetres cubed. Okay, she wants to buy enough tubs to sell at least 200, so we want to know how big 200 of these would be. So I'm going to keep what's in there, I'm not clearing it, I'm just going to multiply that by 200. And we get 18,381.13, but again 5 or more, so round up to 0.14. Okay, and that's going to be, what's that going to tell us? That's this total size, so that's centimetres cubed. That's the total amount of ice cream we're going to need for our 200 scoops. Okay, right. Now, this is where it can get a little bit complicated. We know that 1 litre is equal to 1,000 centimetres cubed. If they're 5 litre tubs, well, 5 litres is going to be 5 lots of that. It's going to be 5,000 centimetres cubed. So we want to know how many tubs we need for this amount of ice cream. So how many 5,000s are going to fit into this? So you could, what we're going to do is we're going to divide. Because the best way to do it is to do the 18,381.14 divided by 5,000. But you can just do it visually and think, I've got 5,000 and I've got 18 and something thousand. So it feels like 5,000, 10,000, 15,000, 20,000. I think I'm going to need four tubs there. But let's do it this way. So 18,381.14, that's the amount of ice cream we need. We know that each tub is 5,000 centimetres cubed. So divide that by 5,000 and we get 3.6 0.76, we round up 3.68 tubs, that's what we need. But you can't buy 0.68 of a tub, so we're going to have to go up to 4 tubs. So as I say, you could see it from 5, 10, 15, 20, but this is doing it more mathematically and using your calculator. But make sure you round up. We can't leave it as this, you'd lose a mark if you left it at 3.68 tubs. Okay, 11B. Susie uses a 15% discount voucher when she buys the tubs of ice cream. She pays £76.50 after the discount. Susie says, I save less than £14 by using the discount voucher. Show working to support this statement. Right, so we've got £76.50. Now this is after the discount. So if you think we've got a 15% discount, we start with 100%. If we take off 15%, 100 minus 15, you end up with 85%. So this figure represents 85%. If we want to work out what the original amount was, the 100% was, well, we need to do £76.50, divide it by 85, because that will tell us how much 1% is, and then we want to multiply it by 100 to get us back to the original amount. So I'll show you. £76.50 divided by 85. So that's saying that 1% would be like 0.90 or 90p multiplied by 100. So the starting price was £90. So she's saying how much she saved. Well, we can find that out by taking the original amount, subtracting the reduced amount, and we get £13.50, which is indeed less than £14. So that's correct what she said. 11C. Susie sells 2 ice cream toppings, sauce and flake. She hopes that the probability that a customer picked at random buys at least 1 topping will be more than 7/10. Okay. The Venn diagram shows what toppings the customers buy over one weekend. Okay, so they can either have sauce on top, 79 of them had just sauce, 104 people had just a flake on top, 161 people had sauce and a flake, and 196 people didn't have any toppings at all. Over this weekend, does Susie achieve the probability she hopes to get? You must show you're working. Right, so we've got to think, well, how many people were there altogether? Well, altogether we had 79 people just with sauce, 161 with sauce and a flake, 104 people just with a flake, and 196 people just with ice cream. So if we add those all together, we get a total of 540 people. Okay, 540 of them. Now, we're interested in the probability that a customer picked at random buys at least 1 topping. So that's going to be the people that have just sauce, have sauce and a flake, or have just a flake. So we want 79 plus 161 plus 104. I don't know why I've written it like that, but that's fine. Okay, so 79 plus 161 plus 104. So 344. So our probability that someone buys at least 1 topping is 344 divided by 540. Okay. But we've got to compare that to 7/10. Well, the best thing to do with that is to turn that into a decimal. 7 divided by 10 equals 0.7. 344 divided by 540 is 0.6. If we do it to 2 decimal places, 6.3 is more than 5, so we round up to 6.4. Okay, 0.64 is less than 0.7. Does Susie achieve the probability she hopes to? No, she doesn't. Question 12. Bees. Mary keeps bees and sells the honey they produce. The bees live in a beehive. Mary's beehive holds rectangular frames full of honeycomb. You can see it's 20 inches across and 9 inches down. Each frame measures 9 inches by 20 inches. What I just said there. The beehive holds 8 frames, so there's 8 of these in there. Mary cuts the honeycomb into rectangular pieces measuring 11 centimetres by 7.5 centimetres. So we're going to kind of like cut this up into bars. Work out the maximum number of pieces that Mary can get from her beehive. Use 1 inch equals 2.5 centimetres. Right, so we've got inches, we've got centimetres. We want to turn everything into the same units. So let's turn the inches into centimetres. So if instead of 9 inches by 20 inches, if we want to go from inches to centimetres, we've got to multiply it by 2.5. So 9 times 2.5 gives us 22.5 centimetres. And 20 times 2.5 gives us 50 centimetres. So in fact we can write that on here. That's 50 centimetres. That's 22.5 centimetres. Okay, now Mary cuts the honeycomb into regular pieces measuring 11 centimetres by 7.5 centimetres. So we've got to think about how can we fit these pieces, or how can we cut them out of this grid here. Now I'm actually going to draw another rectangle because that's got all my inches written on it. I want to have something clearer. Okay, so this is 50 centimetres by 22.5 centimetres. Our pieces are 11 centimetres by 7.5 centimetres. So we've got to think, how can we fit or cut these out of here? Well, 11 and 22, I know that 2 11s are 22. So I can think, well, I could cut one piece here, which would be 11 down, and 7.5 across. Obviously this isn't to scale, it would be a bit wider than that. And then I could fit another 11 down and another 7.5 at the bottom. Because 11 plus 11 is 22, so we can have a little bit of a gap at the bottom that's not used. That little bit there. But that's fine. And what we could do is we could keep cutting out chunks that are 11 centimetres long. 11 there, 11 there. And as I say, we're going to have this little wasted bit at the bottom, but it's only a small amount of wasted bit. So we've got 2 bars or 2 pieces here. How many pieces are we going to get going across? Well, we need to do 50 divided by 7.5, because each one of these is 7.5. So 50 divided by 7.5. That gives us 6.666, but you can't really have 0.66 of a piece, so we can only get 6 whole pieces. So we're going to have so from one frame we're going to have, in fact this is where it's good to do another sketch, because we saw that we're going to split it in to 1, 2, 3, 4, 5, 6 pieces like that with this little wasted bit at the bottom. Okay, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. But remember, we've got 8 of these. There's 8 frames. So we want 8 times 12, which gives us 96 pieces. Right, so the converting isn't too difficult. What can be a bit of a challenge is working out how you're going to cut these pieces. Okay, now we did it this way. We did the 11 going down. You could cut the pieces a different way. So you might see, well, actually 7.5 feels like it's going to go into 22.5. So you could do 22.5 divided by 7.5, and you get 3 pieces that way. Okay. Oh no, not like that. That's not what I meant at all. Do another one. We're saying that you could split them that way, and that would be 7.5, 7.5, 7.5, and then each of these would be 11. We'd have another 11, and to see how many 11s we'd get, we could say, well, 50 divided by 11, 4.54. So in other words, we're going to get, it'd probably be more like this: 11, 1, 2, 3, 4, and then you're going to have a wasted bit at the end. So you would still get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you'd still do 12 times 8, which would give you the 96. Doesn't matter which way you do it. Yeah, hopefully I'm not confusing it too much, but you've got to think about how can you cut these pieces from the honeycomb, and because they want the pieces to be a very specific size, it does mean that you're going to have some wasted at the edges. You're not necessarily going to be able to use it all up. If it was a level 1 question, it would be nice, it would fit perfectly. But level 2, they want you to do a little bit more planning and figuring out. Here we go, 12B. Mary wants to grow some bee-friendly flowers. She finds information about the different flowers produced from 2 packets of seeds. Here's packet 1. Flower A, so this is bee-friendly. Flower B isn't. Flower C is bee-friendly. D isn't. Flower E is bee-friendly. F isn't. Okay. 2/3 of the seeds in packet 2 produce bee-friendly flowers. Mary wants to buy the packet producing the greater proportion of bee-friendly flowers. Which packet should she buy? Right, so we know that 2/3 of the seeds in packet 2 are bee-friendly. We've got to compare it with how much of packet 1 are bee-friendly. And what we can do is we're going to think about our angles here, our degrees. And I'm going to start off actually by thinking about packet 2, because I know that we've got 360 degrees in a circle. And if we've got 2/3 in packet 2 are bee-friendly, well, 360 times 2/3 that gives me 240 degrees. So if these 3 angles add up to more than 240 degrees, then packet 1 is going to be better. If not, then packet 2 is going to be better. Now, what are these degrees? Well, we're going to need to use our protractor. I'm going to start off by measuring this angle here. So we've got to find the crosshairs and line it up with the centre of the circle. And I'm going to start measuring from here. So I want my straight line. I'm measuring the angle, so I need these lines to be in the angle I'm measuring. Line that up there. And here's the line. So we're going 10, 20, 30, 40. Our line here is right on the 45. Yeah, right on the 45 degree line. So that's 45 degrees. We want to measure this angle now. Now, let's do the same way. So we were counting from this way, from 0. So if I want to carry on doing it the same way, I now need to line it up with this line. Okay. So sometimes with this, you then the lines disappear. So I've got to make sure this is the line I want to measure up to. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. This is the one, so that's 120 degrees there. And this angle, well, I'm going to put that on there. Angle I'm measuring is on the inside. So we start with 0, 10, 20, 30, 40, 50, 60. That's the end of that section. So that's 60 degrees. So we want 60 plus 45 plus 120. With total, this gives me a total of 225 degrees. Well, that's less than this one. So we can say 225 is less than 240. So which packet should she buy? Packet 2. That was the bigger number, more degrees. (12C). So this is the last part of this paper. Here are the instructions for planting flower seeds. Use 4 grams of seed per square metre of garden. Mix the seeds with sand in the ratio mass of seed to the mass of sand is 2 to 5. Mary measures her neighbour's gardens to work out the average size garden. Okay. So what she's done is she's used bands. So she said, how many people have got a garden between 0 and 10 metres squared? Well, there were 2 of them. There were 8 people who had a garden between 10 and 20 metres squared, 12 with a garden between 20 and 30 metres squared, and 3 people had a garden between 30 and 40 metres squared. Estimate the total mass of seed and sand mix needed to cover an average sized garden. Right, talking about an average sized garden. So we've got to find out what that average sized garden is first. And we're going to use this to work it out. Now they've said estimate, and the reason that we're estimating is we don't know the exact sizes of these gardens. We just know that they sort of fit into these ranges. So our estimating is using a midpoint. And what that means is we assume, well, if we know the gardens are between 0 and 10, we're just going to say that they're all smack bang in the middle. And the way we do that to work out the midpoint is we say, well, we'll add the smallest value, the 0, and the 10, and divide it by 2. We get a midpoint of 5. So if we want to do that for the next range, we're going to say, well, 10 plus 20, divide it by 2 to find halfway. That's going to be 15. Okay, we can do the same again. You could just say, well, what's halfway between 20 and 30? And you might be able to just see that's 25. But if not, you can do 20 plus 30 equals, divided by 2, you get 25. And halfway between 30 and 40 is 35. Now, we're working out the average, so that's the mean. And if you remember, let's put it down here, the mean is worked out as the total. So in this case, it's going to be the total area divided by how many, or the frequency. So to work out the total area, we need to work out the area of each of these ranges. Okay, so there's 2 gardens. Each of them have got 5 meters squared of area. So we want 2 times 5. Sorry, moving that around. 2 times 5, which gives us 10. Okay. Now we've got this midpoint, we're not interested in these. So all we're using is the number of gardens and the midpoint. So we're going to want to do 8 times 15. So this is telling us the total area of these 8 gardens. And of these 12 gardens, it's going to be 12 times 25. So total area of 300. And for these 3 gardens, 3 times 35, 105. Now we said we wanted the total, we want the total area of all of the gardens. So we've got to add these all up together. So 105 plus 300 plus 120 plus 10. So 535 meters squared. And we're going to need to divide that, so we can put that up here. Divide that by the frequency. Well, how many gardens have we got? Well, we got 2 plus 8 plus 12 plus 3, so that's 25. So 535 divided by 25, that's an average of 21.4 meters squared. Right, that's our starting point. Now, she uses 4 grams of seed per square metre. So we want 4 times 21.4. This is going to tell us how many grams of seed we need. So 85.6 grams. Okay, so now we're going to have to use this ratio. So I'm going to do a ratio table down here. We've got a ratio of seed to sand. And that means we're going to have a total as well. So do a bit of a ratio table. And the ratio of seed to sand is 2 to 5. And if that's all we had, 2 seed and 5 sand, we'd have a total of 7. Okay. Now, actually, we said that we've got 85.6 grams of seed. That's what we need. So we can write this, let's move this up a bit. That's the amount we need. So we've got to think, well, how can we get from 2 up to 85.6? Because whatever we do here, we can then do the same to work out how much sand and how much we're going to need in total. Okay. And the way we do it is we do the opposite. We do it in reverse. So we say if 85.6 is our answer, we're multiplying by 2 to get it. We need to divide by 2 to work out what we multiply by. So 85.6 divided by 2 gives us 42.8. So multiplying this by 42.8. If we want to work out how much sand we need, we're also going to need to multiply that by 42.8. So 42.8 times 5 gives us 214, what's that going to be, grams of sand. Now for the total, you've got an option. You can either add these two together, or you can also multiply the 7 by 42.8. I'm going to do both of these so that you can see you get the same answer. So if we do 7 times 42.8, we get 299.6. But also if we said 85.6 plus 214, we get 299.6. And that's what they've asked us. Estimate the total mass of seed and sand mix needed to cover an average sized garden. We can just write it clearly, 299.6 grams. And that's the end of the paper. So I found that quite a challenging paper. I hope you did too, because challenging is good. It means you're pushing yourself. Fair bit of algebra there. You need to have good calculator use. So go over any bits that you weren't sure about, see how you got on. Like the video, subscribe to the channel, make sure your notifications are on so you find out when I upload more videos, and look forward to seeing you again soon. Thank you.